Today I'm going to be talking about social networks, as Brian said, but I'd like to start off by just saying thank you to you all for being here, and to Brian, especially for inviting me to give a talk today. And the work I'm going to be presenting is joint research with my colleagues at MPI. So Daniel Redhead and Richard McGower helped me a lot in the development of some of the statistical tools I'll be talking about. And at the later half of the talk, the empirical work I'm doing is joint work with Dan Pizer. And to kind of give a little bit of flavor of how we work at the Max Planck Institute, I've kind of broken the talk into two sections here, kind of paralleling the way we approach anthropology at MPI, which is on the one hand, we focus a lot on the development of data science. So we want to develop statistical methods for doing anthropology, methodological pipelines, and we want to often test our methods with simulated data. So part of the workflow we do is put together theoretical models, generative models of data, and then we go out to the field in the second part of the research process and collect that same kind of data. And we do this because a lot of the time the statistical tools we're using are fairly complicated models. We want to know that they work. So we test them on simulated data and then try and recover our parameters. But it's this joint approach to doing research where it's developing pipelines and then also collecting the fieldwork data we need to test the models that we've constructed. So on that note, like the first half of the talk is going to be broken down into discussing some of the tools we've developed recently in the last year to do social network research. So one of the R packages we're presenting is called DieTrying, and it's designed to collect roster-based static data, so social network data, and to run economic games, similar to what the games MatchSurvey has developed. And then there's also this package called Strand, which is designed to analyze social network data using generative Bayesian models, rather than some of these permutation methods that are currently the most popular tools in the field. And then in the second half of the talk, I'll move on to showing how these tools can be applied in a kind of tutorial workflow using data I've collected from my field site in Colombia, where I'm looking at how ethnic parochialism, so expression of in-group favoritism and the extent to which conflict might be directed towards out-group members, is affected by inequality and perceptions of inequality. So to kind of jump into the first part, I'll be talking about DieTrying. So as I mentioned, this is an R package that's designed to improve the ability of researchers to collect large-scale data. Collecting network data can be hard, especially using a roster-based method, because it requires basically every person in the community to give a response about a social tie with another person in the community. And it can be fairly difficult to scale if your populations are large. So to make it work, we needed an R package that could deal with this kinds of data, entering it and processing it. So this R package is specifically designed to run the rich games, like I said, that MatchSurvey developed. So these are generalizations of games like the dictator game to a whole array of individuals. So here, Matt is having a research assistant play these games where a certain amount of tokens are distributed to a focal respondent. And they get to choose, who in the community needs this money, who in the community should receive this money. So the focal player can distribute it across an array of individuals. So rather than running an economic game where you basically just get the focal characteristic, how generous is one person? You get how generous is one person, but how is that generosity directed in a network of individuals in a known community? So when I first came across this paper that Matt put out, I thought this is an incredible approach to doing anthropology. And it's really well suited to comparative research because we can collect the same kinds of network structured behavioral data, getting both positive ties through the giving game and also ties of animosity or conflict through a costly reduction game. And then we can compare that across a wide range of anthropological field sites. So we can study how not only focal characteristics influence behavior, but also how the characteristics of alters influence behavior. So we could look at the extent to which people who are most at need in the community are preferential targets of receiving giving. We can study how much group identity diversity impacts flows between sub communities. We can look at the effect of kinship and all kinds of other covariates. So these games I thought would be a really powerful approach for anthropology, but they're hard to run for the reason I mentioned, in that collecting dyadic data can be particularly time consuming. And so above and beyond just running the economic games, once you put together the photo roster that you need to run these rich games, you can collect a lot of other data on the network as well. So you can get simple tie elicitation by asking individuals to put tokens on people who they're friends with. And you can also collect full dyadic peer ratings data. So you can ask individuals to name, who in the community is most prestigious, most dominant, who in the community elicits fear among other people. So you can get really rich data. This is why Matt chose this acronym. But like I said, when you have to ask each focal respondent in a community, say of 300 people, to do a classification, of all of the people in their network, it can be a really time-consuming process. So DieTrying is designed to take this method that Matt developed and allow it to scale up to larger field sites. So in the past, before we had network structured economic games, if we wanted to measure how cooperation is structured in networks, like in anthropological field sites, we had name generator based questions we could use. So we could ask people in the community, can you list off the names of individuals who you would give to if they needed to, or who you would go to for a loan, or a lot of these hypothetical questions. Likewise, we can ask them, questions about real world behavior. So who did you give to? Who was given to you? Who are you friends with? But each of these kinds of approaches to measuring cooperation in a network has some pretty severe downsides. The first question, it's not necessarily informative because talk can be cheap. People can exaggerate. A person who's not really generous at all might report, that they've given to a lot of people or that they would give to a lot of people. Likewise, people can forget. So it's hard to know that the ties we're eliciting are actually true ties. The second approach is also problematic in that people are often operating under constraints. So some people in the community might have a lot of cooperative proclivities. They would desire to help others. They're not necessarily selfish, but if they're under constraints, if they're poor, if they don't have money to give, then we can't simply use observational data on transfers to infer how cooperative a person is. So true cooperativeness can be masked by constraints. So in the past, in other forms of data collection, these issues with measuring cooperation via self-reports have been fixed. So in maybe 20 years ago now, these economic games came into the field of anthropology, and they were incredibly influential in allowing people to measure cooperation where people can actually put their money where their mouth is. If people want to say they're generous, they actually have to risk their own, they have to give up their own rewards, their own money in order to show that cooperativeness. So there's a belief that these games are better able to capture cooperation than self-reports. Nevertheless, they're not perfect, and they only allow us to really measure the cooperative proclivities of individuals. We can measure focal effects, say. So we can look at, does an individual who is of a particular religious category versus a non-religious category, are they more likely to leave more resources for other people in the community when we set up a certain kind of vignette? So we might say in this paper, like by Lang, do people who are religious, are they more likely to be more generous in a dictator game set? But it doesn't allow us to get at the effects of dyadic characteristics. So, are people who are of the same religion more likely to give to each other? Unless we set up these economic games, in the context of a vignette, say, where we say, imagine you're playing this game with somebody who's of your same religious group. We measure their dictator game allocation. Then we say, okay, and now imagine you're playing this game with somebody who's non-religious or of a different religious group. We measure that allocation. So we can get at what we call target effects, the effects of the imagined other in these games by having a vignette, asking multiple questions, and then looking at the contrast. But the thing is, that's fairly inefficient, and the data you get from it, it's really constrained to just addressing that one target effect. The rich games are much more general in that, yeah, we can recover focal effects because we can see how much each person who's playing these games has given to everyone else in the community. Overall, we can measure the generosity that way versus how much they left for themselves. But we can also extend it. So rather than having to use these vignettes where we say, first imagine playing with some anonymous same community member, we can actually have them allocate resources across an array of known individuals and infer those target effects directly, because we know whether or not two individuals in the community are of the same religious group or not. So it's really natural to extend the power of these original dictator game and a lot of games like that from a form where it's just focal based to a form that's network based. And that's what Matt has done. And it gets away some of the problems with comparative research using economic games, in that, if we imagine somebody in a small scale community where almost everybody's kin is playing this game, and we ask them to imagine an anonymous same community member, they might infer that that person is a kin. So they might behave much differently, say, than a community in a much more market integrated area where most people are non-kin. So the differences in the dictator games might depend on how people are imagining this non-anonymous other. Whereas when we play this games with a network structured format, like in the rich games, then we know that transfers are being directed towards specific known individuals, and we can better, more precisely measure these effects of alter characteristics. So these games were introduced by Ruckus and Winking and colleagues, and like I mentioned, developed by Matt Gervais to specifically look at 3 games: an allocation game, an exploitation game, and a costly punishment game, which I'll explain in more detail later. And then recently, in the last couple of years, we've gone on from Matt's preliminary validation of these methods, and we've tried to really precisely look at how much external validity do they have. How, if we were to play these games and we estimate, say, the effect of kinship, how closely does that compare to if we were to analyze social network data on observed resource transfers? So before I go into the details of doing the external validation, I just want to kind of describe what these games look like from the perspective of a research participant. So in the first game, the allocation game I mentioned, the focal person shown here on the left has a stack of coins or tokens that they can choose to allocate to anybody in the community who they wish to. So the pre-game state looked like I just showed. The post-game state, they just place tokens on a photo roster, and they can place them on anybody, including themselves. So this person saved 2 coins for themselves, and they gave 2 coins to the man at the top and 1 coin to the woman at the bottom. And this is the data the anthropologist would record. There's also a second game, an exploitation game or a taking game, where the pre-game board state looks is shown. The focal individual has no tokens in their hand or anything, but the board, the photo roster, has a coin pre-placed on every individual. And the player is told, the people who are on this board will currently have this money in their bank account, but if you want, you can take it from them in order to put it in your own bank account. So rather than measuring, positive ties that we showed above, this game is kind of designed to measure, who people respect or who people have contempt for, like who they don't care enough about to take from or exploit when they have the opportunity to exploit. So then the post-game board state would look like this, where the focal respondent has taken from some people, but left coins for others. And the last of the 3 games is a cost reduction game, where the focal player starts out with a stack, say, of 10 coins and a stack of 10 punishment tokens, and they're told, you can either keep the money for yourself, or you can use that money to purchase tokens, which you can place on one of these pictures to reduce their payout by 4 to 5 times, what it cost you to purchase the token. So we can use this kind of game to measure negative ties, who people might dislike. And the post-game board state will look like something like this, where they start out with 5 tokens and they place 3 of them, and they've kept $2 for themselves. So in the past, a lot of economic games have been criticized for their ability to map onto real world behavior. And in some economic games, they don't tend to map well onto real world behavior, but these rich games we're finding do tend to map well. So here I'm showing that result. So if we look at the very left-hand column of transfers, this is the self-report food and money lending network data I collected in 2016. And then the 3 most right columns are economic game data I collected in 2017. So a year later. So it's not necessarily designed to measure the exact same thing, but I'm going to show you how closely some of these effects do map on. So we can start by looking down at the 3rd row labeled dyadic. So in this case, we find that in both the allocation game and the true transfer network, we recover almost quantitatively matching estimates of the effects of dyadic characteristics, like being of the same sex, being of the same ethnicity. We cover the same affective relatedness and friendship ties on the probability of a transfer in the allocation game and on the probability of a transfer in this true social network data. Similarly, we recover a lot of the focal and alter characteristics. So what we find here looking at focal, for example, is that people who are depressed or elderly are less likely to report making transfers in the real world data. Similarly, in the allocation game data and the leaving game data, we find that those same categories of individuals are less likely to make transfers to others in the community. So we recover not only these dyadic effects, but the effects of focal characteristics and of alter characteristics. So if you look at people who have high grip strength, for example, they're less likely to be given coins in the allocation game or in the leaving game. And they're also less likely to be given food in the self-report network data. So we do find quite a bit of external validity to these rich games. But we're able to capture some effects in the rich games that we don't capture in the network data. So for example, people in the network data who are food insecure, as I've highlighted here in red, they're less likely to report making transfers to others, but it's not necessarily because they're less cooperative than anybody else in the community. It's just that they don't have food to transfer. So what we find then, comparing on the transfer network to the allocation game network, for example, once we remove that constraint, once we provide coins to everybody in the community, and we can see who people would give to if they could, there's no longer an effect of food insecurity on giving. So in other words, people who are food insecure, they still give to others. And if we look at the alter characteristics, say, people who cannot work or people who are food insecure, they're preferential targets of giving in these rich games, but they're not necessarily preferential targets of giving in the self-report network data. Why? Because in these games, we've provided individuals in the community with money that they can use to play the game. So they can give to people who normally they wouldn't be able to due to their own resource constraints. And then above and beyond simply playing these three economic games, once you have a photo roster, you can collect a lot of really nuanced, I guess you could say, data on dyadic relationships. So one is you could just do simple tile elicitation. You can use tokens, for example, and you could ask individuals to nominate their friends. Collecting network data this way with a roster, it tends to be a little bit easier for the anthropologist to do. First off, because there's a prime, so people are less likely to forget ties because they can actually see each face on the roster, so they're more likely to nominate all of their true ties when you do this. But above and beyond that, if you do this with a name generator, like is really common in the field or in the DAO project that some of the listeners here are participating in, it can be challenging to link the names people give you in this question when you say, can you give me the names of your friends, the 5 people you spend most time with? People might forget. They might nominate people who aren't on the roster. They might use nicknames. There might be multiple people in the community with the same or similar names. It's really hard to link a name to a unique ID using the name generator method. But if it's a roster-based method, even if they have the same name, they have unique faces, unless they're like identical twins or something. So it's really easy to link names to IDs this way. And then you can also collect dyadic peer ratings data with a roster using like Likert scale kind of questions. So you could ask individuals to place purple tokens on people in the community who they find to be very trustworthy, and blue tokens on the people they find to be very not trustworthy, and then green tokens on people of intermediate trustworthiness, and then no tokens of people that they do not know well enough to rate. And you can collect data on reputation like this, prestige, dominance, all kinds of important characteristics. And then in the future, we could compare these kinds of data in a cross-cultural framework. So for example, we could collect this kinds of rich games data and associated dyadic data in a large number of field sites and look at what explains assortment among cooperators. We could test more specific questions like are maternal uncles more likely to make transfers towards their sister's children in matrilineal societies and patrilineal societies? Because by playing these rich games and actually studying what kind of dyadic characteristics predict transfers to flow between individuals, if there's a site level covariate, then we can just see if the effects of that predictor like kinship change as a function of that site level covariate. Beyond that, we can look at things like reputation. So we could ask, for example, if people who have reputations for being selfish or stingy are more likely to be exploited in the taking game, or if they're more likely to be punished in the cost reduction game. And we can do that controlling for dyadic characteristics. So this allows us to test things like negative indirect reciprocity or reciprocity. We can see if there's effects of not only a focal person's view of another person as selfish, but whether or not, if many people in the community have rated that person as selfish, if that's likely to elicit punishment. And then more generally, the rich games allow us to look beyond the effects of simple focal questions. So like if we wanted to ask, do individuals show parochialism, and we just use the setup like we showed in that Lang paper about religion, we might get an answer about religion, but we don't get to see how people trade off when there's multiple heuristics. So in the set of games like the rich games, individuals can make their allocations without us having to do any kind of priming to set up a vignette. So when they can give tokens to anybody, we can see, does ethnicity predict who they're giving to, or does need predict who they're giving to? And we can actually see, is one of these heuristics more powerful than the other when people can make an allocation based on any kind of criteria they choose to. And then again, we can see how this varies by cultural context. And I'm going to give a more detailed explanation of this at the end of the talk. All right, so these games seem like they're really a powerful tool for anthropologists to use, but there is an elephant in the room. And the first kind of objection people might have to running these games is that the data are really hard to analyze. And that's true, but people very often collect data that are hard to analyze, and they find a way to do it. I think what's stopping these games from being taken up by researchers is actually that it's really hard to collect this kinds of data. And to kind of explain why, I want to introduce big O notation here. So anthropologists typically, their data collection protocols fall in one of two of these lines. So people who get data from the World Value Survey, their data collection burden scales like big O of 1. It doesn't matter if you want to get data from 10 people, 100 people, 1,000 people, 10,000 people. All you got to do is just click a few boxes, and you get a really large sample size. For field anthropologists, it's quite a bit more challenging. Our data collection protocols tend to scale like big O of n. So in other words, if you want 10 times as many people in your sample, well, you've got to stay in the field 10 times as long. Or you might have to hire 10 times as many research assistants or collect 1/10 as many questions. But collecting static data like the rich games and static pair ratings, it scales like big O of n squared. So as you increase sample size here along the x-axis, the time it takes to do it increases along the y-axis at a super linear rate. Because you have to ask, say, 10 times as many people to give you data, but they're also providing 10 times as much data. So it might take much longer to enter that data. So in Matt's case, the sample size was about 50. I'm trying to run these games with about 1,000 people in my data set, but it's not just 20 times more difficult. It's on the order of like 400 times more data collection and entry burden. So to make this kind of research possible, we have to extend we have to extend the ease in which we can collect this kind of data. So that's what DieTrying is designed to do. And it does this through a variety of methods. First, it allows rapid photograph standardization. It automates the creation of survey tools that you use to collect the data, including automatically allowing you to randomize the order in which photographs are presented. And it allows for simplified manual data entry. It automatically constructs a relational database and does some data quality checks. And it allows, at the end, you can actually automatically enter data just using cell phone photographs of the photo roster. So basically, you have people allocate their tokens, you take a picture of it, and then magic happens in R, and you get out a colored labeled edge list that you can use. So for field anthropologists, you might have a database of photos like I show here on the left, where the zoom on the face is not the same necessarily. The photos are orientated in different angles based on how you held the camera and took the pictures. But to play the games, you need something that looks much more like on the right, where the photographs have been standard, so the facial area is the same size, and you can actually use them to collect data. Doing this in Photoshop is fairly easy if you don't have a lot of photos, but if you have 1,000 people to standardize, it can take days of doing nothing but cropping and saving. With DieTrying, there's a single line of code you have to run, standardize photos, as I show here at the bottom, and it opens a two-step process where you can click on one quadrant of the photo to do any kind of rotation you need, and then you do a second click and drag out a bounding box to mark off the approximate area of the photograph you want to say. And at the very last step, DieTrying is going to identify the aspect ratio closest to the one you dragged and dropped that fits what was specified in the function call. So all of your photos will be standardized to the same aspect ratio, the same number of pixels, so they're easy to print. They all come out the same size. Once you have done that with all your pictures, DieTrying will know the ID codes of the respondents based on the file names of the pictures, and it will automatically create a PDF in LaTeX that you can use to collect your data in. Again, just a single line of code to run this and create it. And then once you create the survey tool, you can place real pictures of people on a photograph board like this and bring it to the field and have respondents look at it. And what I've found playing these games is people might spend, like on the leaving game, 10 or 15 minutes, really agonizing over who they should take from. And you can kind of just feel like people are really thinking deeply about the characteristics of each of these people, when they're allowed to take morally, when they're not allowed to take morally. So you feel like the data quality is quite high when you do these kinds of games, in comparison to something like a public goods game, where I've run those in the field, and it often feels like people don't understand the rules as I'm explaining them. So it feels like these are much more valid. After you've collected the data using that survey tool, there's another process that you can use to enter it into R, and then this will, create a relational database behind the scenes for you. This data entry is manual. It works really well for games like the allocation game or the costly punishment game, where you can allocate multiple tokens. But it's much faster than trying to do this in Excel with a spreadsheet. But what I really wanted to do to make the dyadic peer ratings data possible in a quick kind of amount of time was have some kind of process, some workflow where you take pictures of the game boards, and then magic happens in R, and at the other end you get a perfectly coded database. And it turned out that this is actually kind of non-trivial, mostly because although in the manual entry workflow, we kind of already know like what the matrix of IDs is, and it should be kind of easy to map this onto an array of pictures, and then just figure out where there's like a lot of green pixels. But it turns out like even if there's a little bit of skew in the cell phone camera when you're taking a picture of these game board allocations, it's actually impossible to get the grids to line up right. So long story short, I found that there's some people who have figured out how to do this. A little bit of linear algebra is needed, but you can make this happen, and you can straighten out the photos, and all you need to do is have the user click in the four corners of the board, and that provides all the information you need to undo all of the skew and rotation. And then you can overlay this grid, and we figured out the workflow works well this way. Once we can overlay the grid of IDs onto the game board picture and label each of these alters with their ID codes, then it's a really easy process of just comparing a pre-game board allocation photo to a post-game board allocation photo. We do a little bit of machine learning on the images, and we can figure out where the density, the hue density has changed between the pre and post game board state. And if we see, for example, that a lot of blue has appeared in the post game board state, and there wasn't a lot of blue in the pre game board state, well, we know a token must have been placed here, and we can figure out which of the three tokens it was based on the hue. So with this, even if you have 400 individuals in your array, all you need is 4 clicks in one line of code in R to get out a color labeled edge list. So this dramatically scales up the amount of respondents you can have do dyadic peer ratings data, and then not have to spend a lot of time entering it by hand. And there are even some other software programs that allow you to do the straightening of the board games, in which case you don't have to do that by hand either. So you can have this happen in a couple seconds. You can code hundreds of thousands of data points this way. But if you're anything like me, you might be uncomfortable with having machine learning do the classification of the data you spent months out there in the field collecting. So DieTrying also provides a single line of code that you can use to check the classifications. So this will plot all of the classifications back onto the game boards using colored circles. You can kind of visually check that where R believes a blue token has been placed, that there actually is a blue token in the picture. And we've done this now with the sample of simulated allocations, and we find that classifying more than 1,000 images, we have 100% true recovery rate and a 0% false positive rate. So we make no errors in classification with just a little bit of tuning of the classifier parameters. So that wraps up the workflow for collecting dyadic data. We also wanted to develop software that allows us to analyze that data. So Strand is a package for analyzing social network data. And it's another route to analyze network data. So the kind of two most common methods now are some kind of QAP test or ergoms. And these models kind of work by starting with a statistical model that violates statistical assumptions. Then some kind of permutation is done on the data, and then the computer returns to step 1, and it builds up estimates under a null model. It says, if we were to randomly permutate the network data a certain way, and then run the same regression model, what would we expect under a null model? We can compare that to the parameter estimate we got on the raw data, and we can say, well, if the null model is really bad at explaining the data, then we can just use the parameter estimate we got out of our statistical model. But the problem is that this doesn't really work. It doesn't actually account for non-independence in the way that a lot of researchers hope. So Hart et al. Recently published a paper on this, arguing that these kind of common permutation methods in their case, looking at animal social networks, don't actually control for non-independence, and they show that a lot of biases remain. After they published a paper, Richard McElrath at our department said, that's a really good paper, but we knew this in '92. Like, I read the same paper in grad school showing that these methods don't work. Instead, what we should do is define a probability distribution over networks. And if there are special dependencies, rather than trying to say a null model can explain the data, we actually build up a generative model of the data with dependencies. So this goes back to what I was saying at the beginning, that we wanted to create generative models of realistic data, even network data with a lot of dependencies in them. And then once we have those models built, we can collect data from the field and use it to estimate the model. So in his textbook, Richard suggests that the social relations model is really an example of a network-based model that properly can produce and generate simulated data. And it accounts for things that are of interest to network scientists. So if there's variation in degree, variation in out degree, if there's correlations in and out degree, the social relations model handles that. It also allows you to estimate and control for dyadic reciprocity. So there's a lot to there's a lot more nuance in these statistical models. You're actually estimating and controlling for the effects that you care about. And so in our field, Jeremy Koster and colleagues have been really influential in arguing, anthropologists should start modeling network data using appropriate generative models. And they've put, some software together and, advocated that others, write their own software that deals with this. So in my past work, I've done this, but I've had to write it by hand. So the social relations model by hand, it's about 200 lines of code to do, highly technical. So it's not really easy for the typical end user to, write out for their project. So we wanted to make a way that, the typical end user could run, these complex social relations models, social network models, without having to go and write all of that stand code by hand. So a lot of these methods depend on, Bayesian analysis and Markov chain Monte Carlo to estimate parameters. And that's part of the reason that, they haven't been used as widely as some of the other methods. But with Strand, the user now has the ability to write in simple R syntax, so something akin to LM. And then under the hood, Strand is going to build the stand model, a Bayesian model, and then apply it to the data and then return the results to R in the same kind of way that you would use LM or Lemur or some of these other packages that are designed to make complicated models easier for end users. And then Strand has two functions. The first is a simulation function. So often users want to put together agent-based models. They want to look at the effect of network structure on cultural transmission or some other characteristic. Strand allows users to do that, to simulate out network data. And it also allows the users to fit a Bayesian model to empirical data and recover parameters. So here in the second block, I've shown the syntax. So if you're looking at the effect of age and food insecurity on transfers, this is what it would look like, controlling for relatedness. And what's useful about this is you can actually simulate data, and then you can fit a model, and you can ensure that you recover the parameters you expect. So this is a way of testing that your tools are well suited for the questions you have and the data you have. In addition to just the social relations model that Jeremy often uses, we've also put in support in Strand for stochastic block models, which are common in the complexity sciences literature. These models are useful for, instead of just controlling for things like dyadic reciprocity and variation in and out degree, there's often block-like structure in social networks. So there might be different ethnic groups in a community, and ties might be more common between groups than with more common within groups and between groups. So these are the kinds of models that we would use to estimate the effects of these kind of group structure variables. And then it also has support for the union of both the stochastic block models and the social relations model. And this is where Dan Redhead and Richard and I think with these particular controls built into the model, we can really closely approximate what a lot of human social networks look like. So this extended social relations model deals well with some of the issues that we want to control for in human data. Like I mentioned, this is like correlations and in and out degree, dyadic reciprocity, things like that. Also block structure. but it doesn't deal well with probably the most severe threats to validity in network data, namely false reporting, forgetting ties, and question order effects. So I'm going to detail a little bit what those are. And then how we've expanded the social relations model to a latent network framework where we can actually jointly estimate network structure and reporting biases at an individual level, but this relies on double sample data. So to kind of explain what this latent network model is, which is Strand's primary contribution, new contribution, we have here an example of a directed network. So you can think of this as like a loan network or a food transfer network. But when you go out to the field and try and get this data, this might be the true underlying network. If you ask people, you might not get that in your data. So some people might have forgotten to mention ties. So some ties are kind of invisible to the researcher, but they're there in the true network. And then other people might exaggerate. You know, Bob might say he made transfers to like 6 other people in the community. And if the anthropologist just records this and treats it as true, we're going to get the totally wrong idea of the network structure in this community. And it really could be a single person who lies and exaggerates can just destroy network inference for the whole community. You know, so if we were to say calculate eigenvector centrality on the true network back here, and then calculate it again on this network, we would get a completely different measurement. If we were to measure between us, we get a completely different measurement. All it takes is a single, I don't want to say liar, but a single person who you might overemphasize their generosity to really change dramatically what we think about relationships in a network relationship in a community. So we need a way to deal with that. One of the first people to try and tackle this in the field was David Nolan, who did what we call double sampling. So he would go out to the field and ask people to say, you know, who did you give food to? Or he'd ask Anna in this case, did you give food to Bob, yes or no? And record that. But importantly, he'd also ask Bob, did you receive food from Anna? And then, you know, we can see, was this tie mentioned by both individuals? If it was, then we can, you know, be a little bit more confident that that tie truly existed. But if one of them didn't mention it, then we might, or both of them didn't mention it, we might say, okay, that tie probably doesn't exist. So this method of network resolution, it's called taking the intersection of reported networks. So you get double sample data, and then you see, you know, did both individuals in that dyad mention the tie? And what we see is if we compare like the true network data that I used to generate in the simulation, you know, we get one kind of network structure. If we simulate each node in this network reporting both receiving and giving, with, you know, some false positive rate and some false negative rate, and then we use the method Dave Nolan used, we can see, you know, do we recover the true network structure? And we tend to recover it decently well in this case, but what you can notice is that the network on the right is a lot sparser. Because if either individual happened to forget a tie, then that tie is declared to be non-existent, which is, you know, fairly extreme. So we might say that this kind of approach of network reconstruction, you know, generates networks that are a little bit too cold. But if we do the other thing, if we classify a tie as present, if either individual in the dyad reported it being present, we'd get a network like we see on the right now. So this is, you know, taking the union of two reported networks. And this is what most anthropologists tend to do, actually, because if we do the intersection, like was initially suggested, our networks don't look really networky. So we can easily see that there's not a lot of concordance. Two individuals talking about the same tie, their reports are often conflicting with one another. So we really have to find a way to deal with this. So this network is too hot. There's too many ties. It's way too dense. But, you know, if we go back to this true network, and now we take two reports of each of those ties, we can find ways of, you know, fixing these reporting errors and controlling for them. So again, if we imagine some individuals forget ties, and some individuals mention ties that are non-existent, well, we can fit a Bayesian model where we can kind of think about the probability that ties exist as a function of how much concordance or discordance there is. So if we look at Joe, for example, and Anna, we can see that Anna's looks pretty reliable. That is, like the ties she reports, making and receiving, match really well with the reports of the people she's connected to in the network. So we conclude that she has a fairly low false positive rate, fairly high recall a true tie rate. And the same goes for a lot of individuals in the network. But Bob's reports are not concordant with anybody. So a Bayesian model would say, you know, what's the probability this tie exists given that Bob reported it, but nobody else did? You know, well, this is going to depend on Bob's characteristics. And what the Bayesian model will say is, well, what's the probability that all 6 of the people Bob's connected to forgot to recall a tie, given that they recall all their other ties accurately? Probably pretty low. It's much more parsimoniously explained by Bob having a really high false positive rate. So then what the model will do when it comes time to reconstruct the network is it'll shrink all the ties that depend on Bob's reports as having a fairly low probability of existing. So by using a method like this, we can actually recover fairly accurate network reconstructions. And this is going to remove a lot of the biases introduced by reporting. So we drew on some of the insights to, first advanced by Butts and then Young et al. More recently, where we modeled the network data using a mixture model, where we consider 2 processes yielding reported ties, that is, true ties that are actually accurately recalled, and false reports. And there's 2 processes that yield zeros in the network, so that is true transfers that were not recalled and true zeros. And we just build out a model of latent network structure along with individual level reporting biases. And then we fit a model just that does exactly what I described verbally in the past 5 minutes. I don't talk about the mathematical details here because it's fairly complicated, but I refer people who are interested in this to the preprint we released recently. But if we apply that method to the same reports that I showed in the other 2 slides, we find that we get really accurate reconstruction. So the plot here on the left is the true network. The plot on the right is the inferred network using our methodology. And we find that we recover the growth structure quite well, and we get the density in contrast to the other methods I showed. But it turns out that this is actually not accurate enough to be able to really use a latent network approach on data we care about, in that there's a third kind of bias in respondents that severely restricts our ability to make accurate inference. And I'll show with my own data how embarrassing and bad self-report data can be. But this comes down to this kind of question order effect. So Reddy and Power talk about this in great detail, and they analyze a lot of previously published network data sets. And they show that there's this phenomenon basically where people in the first network layer, you ask them, who gave you food or money? And they list some names. And then you ask, who did you give money to? So first they ask about receiving, then they ask about giving. And people tend to say the exact same names. They might even say the same people. And then the question is this true, or is there some kind of priming effect from the first question onto the second question? Like, people might have a bias to perceive networks as reciprocal, even if they're not. So it might not be the case that transfers actually flowed in that second direction, but they were reported as flowing. And this individual level correlation across network layers in the reporting networks can really dramatically inflate things like reciprocity that are standard targets of inference in anthropology. We fix this in our model by doing the same kind of thing, where we model the ties in the true network is coming from a mixture model. But in this case, it's the latent network model that I introduced before. But there's a second kind of bias parameter, which is this response duplication propensity at the individual level that we also account for. And by doing that, we find that we're able to get really accurate inference. So to kind of show you the way we've gone about validating our model, we draw on the fact that we have a lot of computational power at MPI. So we're going to do a lot of simulation tests. So we've done thousands of different parameter sweeps. And then we've also applied it to empirical data that we've analyzed with other methods. So to do the parameter sweeps and kind of set up the plot I'm about to show you, we simulate out a true network of transfers. So you can think of this like as a directed gift network. Then we simulate out self-reported data where people might forget certain ties, they might report ties that didn't exist. And then we apply the 3 standard methods now of constructing a single layer network from multiple reports. So we take the union, which is what most anthropologists do, but which might also be the most sensitive to biases. We can take the intersection, what Nolan recommended, or we can use the latent network model I just introduced. And then after we reconstruct the networks, we can calculate things like betweenness centrality, eigenvector centrality, density, reciprocity, transitivity. We can calculate all of these network level metrics. We can calculate them on the reconstructed data and on the true network, that we could see, how accurately do each of these methods allow us to recover true effects. And what we see here in red is that if we take the union, which is the most common thing that we see people do, we get density completely wrong across the whole range of the parameter values. We get reciprocity wrong. And the same thing is true for the intersection. We get density wrong, we get transitivity wrong, we get eigenvector centrality wrong. We do get reciprocity about right. But basically, what we're doing here in this image is we're, starting on the left-hand side of each of these plots, we have really accurate data. So that's a low false positive rate and a high true recall rate. And as we move to the right, we have a really low recall rate. So people are forgetting like 60% of the ties. And we also have a high false positive rate. So half of the ties or more that are reported are inaccurate. So across this parameter suite, as we move to the right, the data are lower and lower in quality. And data that I've collected, it's not going to be on the left. It's going to be towards the right there, where there's a fair amount of false positive and a fair amount of forgetting. And if we use any of the standard methods, we just can't recover the network level properties we care about. But if we look in orange, those are the estimates that have been recovered using a latent network model. And we find that we can actually recover them exactly, even when the data are quite bad. And then to run this latent network model, it's similar to how I showed at the beginning. All you need to know really is LM style syntax, and you can fit models where you put in the predictors of outgoing transfers, you put in the predictors of incoming transfers, you put in dyadic predictors, and you can also put in predictors of false nomination rate, predictors of recalling true ties, and predictors of this name duplication bias that I mentioned. And then we can fit this model using that LM syntax and look at the plots and see how they compare to a standard social relations model. So using the same data, I find that we recover the same effects of relatedness and friendship on ties in the food transfer network. We recover a lot of the same focal effects. So people who have no food or are depressed are less likely to make transfers to others. We don't find target effects in this model or in the previous one. But then on the right-hand side here, I look at the individual level predictors of false positive rate and the recall rate of true ties, and we find that there's no individual level predictors that are explain much of the variation in the propensity to make false reports. Nevertheless, if we look at the network level, we find that there's quite a bit of forgetting, especially in the network of who people received from. So here I've highlighted in layer 1 where people report who they gave to. We recover about the recall rate of true ties is quite high at about 80%. But who people received from is much lower. So people tend to be forgetting who they've received food from. But it's also quite variable across the population. So if you look at the standard deviation over to the left, it's quite high across respondents. So some individuals are recalling most of the ties accurately, but there's a few people who are predisposed to forgetting. And then also in the question order effect that I was talking about, that name duplication bias, we find that about 25% of the ties mentioned in the second question are like clones of the first question. So it's inflating what the estimate of reciprocity we would get just looking at the network data. So to kind of make that more clear, if I take the union of the reported network data, I would think that 50% of ties in my community are reciprocal. If I take the intersection, I think the 0 are. But if we fit this latent network model, we get about 10%. And that fits much more closely with what I would expect just as a qualitative kind of feel in the community. I know that most of the ties are actually needs-based transfers. So people are giving to people who have less food, who are resource insecure. So we don't expect them to be reciprocal at a 50% rate. That's just a dramatic over-representation of how much reciprocity there is. All right, so that kind of concludes the part of the talk where I talk about introducing the tools we've developed. Now I want to talk kind of briefly about an empirical project where I've used both DieTrying to collect and enter the data and Strand to analyze it, and then show how this workflow kind of works out. And in this case, it's a case study on ethnic parochialism and inequality in Colombia. So I got interested in this topic by working with Ann Pizer, who has done some similar economic gains to get at some of the same questions in Chimani and in other communities in Bolivia. And it kind of is a response to, many decades now of research looking at intergroup bias. So looking at the tendency of individuals to, direct cooperation and conflict as a function of identity group. So in our field, this is most commonly associated with Sam Bowles and colleagues who look at parochial altruism and this tendency to direct cooperation towards in-group members and animosity and conflict towards out-group members. And yet there's a fair amount of evidence that people tend to structure, their social relationships in such a way that group identity impacts how we treat one another. But in the fields of economics and political science, it's led to some, potentially problematic arguments, I would say, being made in some of these disciplines. An example of this might be this idea that, in more ethnically homogeneous community or heterogeneous communities, we tend to see more conflict between individuals. And the explanation there is, well, that we have adaptations for parochialism. So where there's more diversity, there's the bigger scope for conflict to emerge. It's harder to organize contributions to the public good. And then, a lot of these papers have been critiqued recently. So Patersurco et al., lays on the Economist and says, there's a striking claim that, things like national economic success depend on cultural homogeneity. And, it sounds really problematic. People can read this and, it's not hard to imagine a populist leader thinking, if national economic success depends on cultural homogeneity, we should make the culture more homogeneous. It's kind of scary arguments can kind of come from this idea. And it's especially problematic because, some of the data that these economists and political scientists use to make these arguments are ecological level data. They'll take like, national GDP and, some really coarse measure of diversity and run linear regressions on them. Not really accounting for the fact that, there's the ecological inference fallacy and you can't really make those individual level claims. And there's a lot of confounding variables that you might want to account for. And just to kind of, think about intervening variables, when Alesina and colleagues, talk about why there might be these relationships between economic performance and diversity, they'll say like the costs of diversity are fairly evident. There's conflict of preferences when groups are more diverse. Racism can happen in more diverse areas, prejudices, when there's a lot of diversity, certain political powers might, put laws that oppress minorities. And this might lead to, reactive violence and civil war. And all of those arguments seem really cogent. But, and the important but here is that those aren't diversity, racism and prejudice are not like a necessary consequence of a more diverse area. So when we think about, what we title our papers, we might want to focus on variables we might think about intervening on, and it's definitely not diversity. What we'd want to intervene on is, change policies that are racist in origin. We might want to get rid of those things without focusing on diversity as a causal variable, because it's not. It's confounded, or there's some mediating variable that's causing these associations at a kind of gross aggregate level. And so Timothy Waring and Adrian Bell have, made this exact point. And not to put words in their mouth, but they might say that, prejudice, racism, and intergroup inequality, for example, might mediate, this fairly spurious correlation that the economists are finding between diversity and economic performance. So in other words, if we were to, intervene on between group inequality, if we were to intervene on racist policies, then we might not see parochialism emerge is highly in areas that are more diverse. We'd correct for those causes. In later work, Alesina et al. Actually started to focus on these kinds of things. And they actually did find that, a lot of the associations they found in the earlier work were driven by things like inequality. So it's not necessarily in areas where diversity is higher that you see, reduced contributions to the public good or more conflict, but it's specifically in areas where there's a lot of diversity, but that diversity is, structured by racist social systems, but a lot of between group inequality. That's where you tend to see these negative consequences emerge. So kind of reviewing the literature, there's obviously the problem that, we don't want to be making claims about something, especially so politically sensitive, on the basis of really low quality aggregate data. We might want to study it at a more fine scale. So one way we could look at this is by studying site level variation within the same interacting ethnic groups, and then saying, if the diversity is the same, but the context of these groups interacting in one location is, characterized by high inequality, but it's not in another, do we see effects on both sides, or is the effect best explained not by the fact that diversity is different, but by the fact that the nature of intergroup interaction is different? And then we can also study preferences, related to parochialism at an individual network level. And then we can later look at, how certain covariates predict variation in attitudes. So I work in Colombia, and I have a network of about 6 field sites. And 2 of these field sites are on the coast in an area that's predominantly Afro-Colombian, but where there's a small amount of Embera who live nearby. And then 3 of these sites are located on the inland, right on the ethnic boundary between these groups. And the context of interaction is very different, partially due to the ability, the resource distribution of these communities. So I think, setting up a network of sites like this will allow me to look at how the nature of intergroup relationships is going to structure how much parochialism we see. So how much between group animosity we see, and how much within group cooperation we see. So in the coastal site, the Embera community there, which is a Native American population, they've been displaced from their home a few hundred kilometers away down the coast. And the only area that they can kind of live near is this landfill in the Afro-Colombian region. So they're kind of seen by everybody in the Afro-Colombian community as being very marginalized and very in need of help from other people in the community. And just to say why they live here is that they were displaced violently in the 90s, 2000s by a lot of the internal conflicts in Colombia. And they basically had nowhere else to go. All of the other land nearby that was in kind of safe government control, there were already people in that area. So they kind of got moved off to the margins of the community. In contrast, the Afro-Colombians, they also live in a fairly impoverished area, but they have things like access to power. You can see these power cables down there. You can see in the middle of the screen, there's some tubes that bring in fresh drinking water to their communities. They also live on the coast, right on the ocean, so they have access to fishing. There's a lot of really productive tuna fishing grounds that they can reach nearby, and there's more material wealth here. So a lot of the Afro-Colombian families will have access to boats, as you'll see in a second. So this leads to a perception of wealth inequality in the community where Afro-Colombians see themselves as the haves and the Embera as the have-nots. And the Embera perception is quite the same. They see themselves as the have-nots and the Afro-Colombians as the haves. However, the inland site, the nature of interethnic relations is quite different. Here, the Afro-Colombians perceive the Embera as being the haves. So rather than being this, small population that's kind of marginalized, I see the Embera as living on a resguardo, as having a lot of protections under the Constitution that the Afro-Colombian communities don't have. They see the Embera as having access to markets to sell artisanal necklaces and bracelets to tourists. That, so they have this, way of building income that the Afro-Colombians don't tend to have. And they also see that the Embera have a lot of material wealth in this community. So they see them driving jeeps up and down the mountains. And this leads to a certain characterization of need in the minds of Afro-Colombians about Embera that's different than what we see on the coast. And the Afro-Colombians here on the inland side, they see themselves often as the have-nots. There's a lot more variability here within the Afro-Colombian population in terms of, well, some people have really nice houses with glass and metal, but a lot of people live in really rundown kind of shacks with really low material quality. And they spend all day doing things like panning for gold, where it might take several hours of labor to get just a few pennies worth of gold, or just digging sand to bring up to the roads to sell. So really, doing subsistence activities that take a lot of effort that yield very little financial rewards. So this is going to change, who they see as most in need. So we can run the rich games in each of these communities. We can collect data on food transfers and friendships. And then we can analyze them with the tools I just showed and to look at, how much are cooperative relationships directed towards the in-group versus the out-group, and how this is affected by this difference in context. So this plot is quite a bit dense in terms of information, But I'm going to kind of focus your attention here. The first thing to note is that the coastal site estimates are plotted in blue and the inland site estimates are plotted in orange. And then the only estimates you really need to pay attention to are here in the parochial row, where the top line of estimates come from the Afro-Colombians and the bottom line come from the Embera. And what we see first off is in the reduction game, there's no evidence that costly punishment is affected by ethnic identity. So in contrast to a lot of the work that's argued that humans are fairly parochial and that we direct cost towards our group members, we don't find any evidence of that here. These groups get along quite well. So in the literature, a lot of study of ethnic relations has been focused on areas where conflict is high. In this particular group, the Afro-Colombians and the Embera have got along quite well for most of their history, and they mutually supported each other. And that's kind of shown here in the fact that we don't see any evidence of costly punishment being affected by ethnic identity. If we look at the friendship network or the allocation network, however, we do see evidence that individuals in both communities, in both ethnic groups, are more likely to have friendships with people of the same ethnic group as themselves. And they're also more likely to direct transfers with people of the same ethnic group as themselves. But looking at the allocation game, we find that at the coastal site, there's less extreme evidence of parochialism, and that parochialism is muted by the fact that both groups agree on whose need is greater. So there's less parochialism expressed in that context. And this is even more clear if we look at the transfers or especially the leaving game. So to look at this, on both inland sites, the Afro-Colombians and the Embera there both show extremely high levels of parochialism in that they prefer to take coins from the ethnic out group and leave coins for the ethnic in group. Whereas at the coast, we see the exact opposite actually. So in the model with no controls in the light blue, the Afro-Colombians are actually leaving for the ethnic out group and taking from the ethnic in group. So when they see that one group is in need, that heuristic to help those in need is stronger than any kind of heuristic to direct transfers towards your in group, direct cooperation towards your in group. So it shows that this is a fairly conditional kind of heuristic, and that people can change based on the context they're in, how much parochialism they're going to express. And then to kind of just give some context ethnographically at the coastal site, Afro-Colombians would say that they left coins for people who are indigenous, the sick, people of old age, and they were clearly cognizing the Embera residents as into people who deserve special consideration on the basis of their need. And the Embera, although they were taking more from Afro-Colombians, they would contextualize their taking by saying, we took from people who already have money to live on, people who already have jobs, and they left coins for people who are their neighbors or people who are in similar situations to themselves. So although if we just look at the quantitative data, it would look like, yeah, they're giving to people who are of the same group. It's not necessarily that the group identity was what was causing the transfers to be allocated in that way. But it just so happens that, the Embera were also seen as being more in need, and they're also their neighbors. And at the inland site, the difference was that the Embera here were describing taking from the Afro-Colombians because, they're bad people that don't cooperate with you and you ask for help. You're hungry, you ask for help, and they do nothing. And there was a lot more social friction at the inland site. Why was this? Well, it was because the Embera in my particular sample actually are fairly impoverished compared to the Afro-Colombians. But the Afro-Colombians perceived all Embera in the area as having the same level of resources as the people on the resguardo next door. So in this way, both ethnic groups perceive themselves as being the most in need, and they're both acting on the same norm to help those most in need. But this was leading to a lot of social friction because the Embera there still continue to see themselves as most in need. So I'm pretty much at a time, but I find that the transfers in this community, they tend to be structured as is seen in a lot of other communities where similar games have been done, in that transfers tend to be based on need, and that tends to be the norm that's governing transfers. It was more salient than ethnic identity. but also in contexts where, we see ethnically structured inequality and wealth or power. It's not a surprise to see individuals directing resources towards people in their same communities, wearing and built on similar things. But on the coastal site, when we see that ethnicity and need are perceived to co-vary, then members of a well-off group might use ethnicity as an indicator to direct needs-based transfers. And this can attenuate the expression of parochialism in a way we didn't see at the inland site. And then in future research, I hope to start looking at individual level predictors of the extent to which individuals express parochialism. So on the coast here, if we plot the leaving rate for the outgroup versus the leaving rate for the in-group, we find that the Afro-Colombians, they're leaving more for the outgroup than the in-group. So it doesn't appear that there's, a universal expression of parochial norms. However, the inland community, individuals are generally leaving less for the outgroup than for the in-group, at least the Afro-Colombians are plotted in blue. But this is a really variable estimate across individuals. So within the community, some people are up here and giving a lot to the Embera compared to Afro-Colombians, but some people down in the lower region of the plot are giving more to the Afro-Colombians. So the question is, what explains this inter-individual variation within a given community? And I think, in the future, we might find that those people up at the top of the plot in dark blue, circled in dark blue, they're giving more to the Embera because, they have social ties. They have a more accurate perception of the need of those individuals. And that's something I have data to get at, but I haven't yet analyzed. So I basically settled this points already, and that kind of wraps up my time. So I'd like to thank you all for being here and listening to me. And I hope it was decently easy to follow. And I thank all of the people in my field sites who have given a lot of time to provide me data, and to all of my colleagues at MPI who have helped me to analyze it and put together some of these tools.
Thank you. Thank you very much, Cody. Thank you. Well, I understand there's quite a bad echo effect going on with my audio, so I'd appreciate it if we just sort of self-organize the Q&A, and whoever has a question just jumps on the line essentially and poses their question straight to Cody, and we can just run the Q&A in a more distributed fashion like that. So as soon as anyone who cares to, just speak up, and please, Cody will field your questions.
All right, well, since no one else is speaking, I will. Hi, Cody.
Hey, how's it going?
Really nice work, thanks. And as you know, I'm a fan of your work, and of course, people like Richard and Matt and Anne. I think the field of anthropology, this work is really important. And I think in the latter part of your talk, you certainly made a good case for why that this approach and the results that it can yield are important beyond the somewhat limited questions that we typically explore in anthropology. But I wonder whether, from the perspective of this sort of greater good around the world and the pressing needs, to a certain extent, we aren't kind of, with regard to the tools that you have in hand, we're kind of fiddling while Rome burns, right? So you tell me, but it strikes me that there might be enormous public good in using these techniques for contact tracing, right? That there are errors of recollection, there are biases in self-report, structured biases in self-report in all kinds of contact tracing situations. Obviously, the COVID pandemic is the pressing urgency right now, and there are small armies of basically novice, undertrained, underskilled, and under-equipped contact tracers at work. But then we're also seeing, a resurgence of, say, syphilis in the United States, right? Where a lot of the kind of biases that can shape the data might be even more prominent than they are in contact tracing for something like COVID. So even as I encourage you to continue to advance the work that I think is really important at the basic science level, I wonder if you've thought about or you see opportunities to apply it to public health concerns.
Yeah, I think it's a really good point. So, yeah, like data like on like needle exchange networks that people have tried to analyze are plagued by this bias and inability to report and recall. And yeah, that's going to dramatically, influence what you'd think about network and risk. Yeah, I mean, I think it's a good point. And I think that's, a lot of the insight into the people who really, started deriving these latent network models were driven by, trying to address a lot of these applied questions. And then the problem is that, to build those models up for a field researcher is quite difficult. So we're trying to make it easier to apply these models. And, depending on how you go about getting the data on contact tracing, you might be able to use, something like Strand to analyze that data and actually estimate the extent to which, certain people are underreporting contacts. Because you're estimating the latent network structure. And if other people in the network report having a tie with this person who doesn't report making ties with others, you'd be able to recover that. And then you'd possibly predict that propensity to not nominate ties as a function of their individual characteristics, whether it be political orientation or other things.
I would go even further than that in urging you to use these tools. So in addition to Strand, I can see utility of a version of DieTrying where, if recall is better, recognition is better than recall, right? And especially if you're talking about something like, needle sharing or sexual partners in a promiscuous community, people may not even know the, full features of the identity of others in the network, right? And if you were to adopt the high-tech version of Matt's techniques, in terms of presenting people with arrays of possible partners in a network, right? And the technology to automate the data entry and processing parts of it, then conceivably these could be really, really important tools in public health.
Yeah.
Hi, Cody. I guess if we're self-selecting, I will go next. Great to see you. Thanks for the talk. I had a couple questions, but I'll just start with one. You mentioned earlier in the talk that the rich games have higher external validity than some of the other field experiments, and I think I can see some reasons why they would, but I could also see some reasons why there's still some gaming that people could do that might not, or other kinds of things that might undermine external validity. I wonder, could you just say a few more words about like what in your view are the kind of important ingredients for having high external validity games?
Yeah, well, so I think part of the problem with game, I think like Jeff Winking has looked at this with like the public goods game, is that it can be fairly complicated to explain like what's actually happening, and it's not a context that people might be that familiar with. But a game like the rich games, where you have an individual, and the only thing you have to explain to them is that they have to put tokens on a given individual's picture, and that person is going to get the money. I think that's a lot easier to do than imagining they're going to make a decision with a random person in the community, or you're going to have to add money to a pot and divide it, multiply it. So I think it because of the priming, because they can see that these transfers are going to go to specific individuals, and they're going to give a specific amount of coins. It's something that is maybe a lot more comparable across research contexts. And then we can, try and evaluate, how much external ability do we have by having a game and then having, some kind of social network question that's, getting at some of the same kinds of network relationships. So if it's, given the allocation game versus like a money sharing network or a food sharing network in a given site, we can see, how similarly do these networks look, when we collect the data, and do the same focal, target, and dyadic predictors, predict transfers in both networks.
Okay, that makes sense. So essentially what's going on there is that it's transparent, what the person's being asked to do.
Yeah.
But then you could still, so sometimes I worry about presentation issues, and it seems like that's not going to fix that necessarily, right?
By presentation issue, what do you mean exactly?
Well, who you are and that you're asking them to make a judgment and that you're going to know what it is. And
Yeah, so that's still there.
yeah,
But if we go back to the slides real quick, you know, you might want people to perceive you as being a good person and give to a lot of others. That's still there, but you have to sacrifice money to do it. So that's, you know, the motivation for using an economic game as opposed to a self-report question or a vignette to get that kind of data. But if we look here at, like, in the bottom left-hand corner, those are people who left for nobody. So there's still a lot of variation in these games, and people who want to take from everybody, they do take. It's not like we see like all of these points clustered towards one of the boundaries. So they're highly variable across respondents, and that variability is predicted by some of the individual level variables we think would cause variation in generosity.
interesting. I mean, another way of thinking about that might be, because there's a sort of a bimodal distribution here, you know, that there's underlying types that have to do with how people approach the game, where maybe the people in the upper right are the people who are sort of approaching the game as with some sort of goal of who am I altruistic towards, and then there's some other set of people who are just like, I'm going to take all the money,
Yeah,
get rich and die trying. Could you model that? I mean, is that something that you do in the models? Because I mean, it seems like if you had another parameter that says operating in, I don't know what you'd call it, but some kind of motivational parameter, you could maybe capture some of that variation.
Yeah, you might be able to do it. I haven't really thought too carefully about that particular bias yet, or how to address it. It's, you know, and I think of it as like I'm just modeling the behavior that was done. And the behavior in this case was allocating coins, and whatever motivated it more proximately, I've kind of just black boxed, I guess. But it's something you could conceivably do. You could conceivably get at it.
If I could just jump in here, I think, I mean, I share Clark's concerns, you know, about the impression management aspect of any, you know, experiment or interaction. But I think if I were to channel Matt, what Matt would say in response to that concern is, well, you know, this maps onto other data that are external to the game, which is what Cody said just a moment ago. And B, I think Matt would, if I remember correctly, it's a number of years ago now, but he would say people say during their decision tasks, they provide explanations for things, why they're making, you know, these, you know, recipient identity condition choices that are not necessarily complementary, right? In the sense that, you know, well, I hate that fucker, right? You know, that guy, I'm going to take all his money, right? Because I remember the time when, and if it were, you know, if their decisions, at least for many of the participants in many situations, this doesn't address the bimodality, but, you know, if it were that impression management was really looming large, the way, for example, that it probably does in things like dictator games, anonymous dictator games, for a lot of populations, they wouldn't say the things that they say, right? I mean, Matt's not here. We can ask him at some point in the future, but I think that that's what his response, his defense of those techniques would be.
Yeah, I agree with that. And I did a lot of the same qualitative follow-up questions that Matt's done, and I got a lot of the same kind of responses. There is, you know, some sense in which a lot of these games people say, like, I didn't take from anybody, you know, because a good person doesn't do that. They don't take, or, you know, God's watching. The only person that can judge and you know, take from others is God. Or like in the punishment game, that's what they'd say, you know, I'm not going to punish anybody because that's not my role. Other people would say, yeah, I dislike this person, or like, you know, they slept with my husband or something like that. So that's why they're getting the punishment token. So you can kind of see motivations, you know, that map onto, you know, the kind of drivers we think would cause people to behave in certain ways. But there might be some, especially, you know, the people who left for everybody, that might be driven in some part by, you know, how they want, you know, the researchers to perceive them. I also don't see if anybody like raises their hand virtually, so I just feel to just ask questions.
Maybe it's gone quiet. Put a hand up.
I have a kind of sociology of knowledge question, which is, I think that the critiques of the macro scale economic publications with regard to the consequences of diversity are well framed, and the data like those you present here, certainly at the very least complexify the picture. I'm curious what that debate looks like, whether that debate is taking place in publications, what the response is to those kinds of to critiques like those that you've leveled.
Yeah, well, let's see if I scroll a few more slides down here. So in the context of the political science, like the quote I gave from Patasurco, talking about how this is a kind of shocking claim. If you compare it to what's actually said in the Alesina papers, it's not nearly as strong. So I think the economists, they kind of see these as being fairly reasonable models. Why is public goods contributions lower, for example, in communities that are more diverse, like in America? Well, the dynamic that they describe is just as the diversity in an area goes up, they find that white people in those areas tend to stop contributing. So they'll vote for lower tax rates and things like that. As soon as that that allocation starts being divided amongst a group of individuals with more diverse preferences of where the money goes. So it's I think the economists, they really do see this as being caused by racism. It's just that they describe it in the titles and the abstracts of their papers as if it's due to diversity, but it's not due to diversity. It's due to a lot of mediating mechanisms that happen to occur in areas that are more diverse. So I think the way they think about the issue is it's not really problematic language that they're using. They're describing mechanisms that lead to an association between diversity and sociocultural outcomes that are not that great. More widely, there's a lot of research into ethnic conflicts. So in the Balkans, Rwanda, and it's important to study those topics and look at why is there a sixth of a nation was killed in a period of only a few months across an ethnic boundary. Why would we see such extreme violence happen? So understanding the kind of psychological processes that lead to that is really important to do. But even in that case, it was driven at approximate level by inequality between groups, how individuals in the out group were characterized and treated. There was also different laws for people of different ethnic backgrounds. So if somebody was convicted of murder in one group, there was a certain punishment for that. It might be a kin was killed, but if you were the other group that committed the murder, then the punishment was twice as extreme. So there's a two kin for one kind of punishment, and that kind of difference in treatment, was something that ramped up the violence that occurred. So I think it's important to look at where does conflict emerge and why, but also to be a little bit more nuanced in the mediating mechanisms. Yeah, fuck.
Yeah, I have another question. Thanks. Also sort of a methodological question, since you talked about methods quite a bit and made a lot of methodological innovations here. Could you say a few things about what you think are the limitations of using statistical methods to infer psychological biases? Because you framed this as, I thought the method that you used was great about the double sampling, the social networks and all that stuff, but then you sort of mentioned forgetting the ties, which I guess you could use as a shorthand for any reason why someone might neglect to mention a tie. But obviously there's other processes other than forgetting, right?
Yeah.
So, and then, I always wonder a little bit when I worry that when we take statistical methods, I wouldn't want it to become entrenched that everything that you find there should be lumped under the category of forgetting, right? Do you see what I'm saying? So because there's this whole statistical ritual problem, right? Where we kind of create the statistics and then it's okay, we ran it through that machine and that's the answer. And so I guess I'm asking you just to, what do you think the limitations of using that kind of?
I'm using it as a shorthand. I definitely don't mean necessarily the psychological process of forgetting. And there could be other reasons why names aren't mentioned. Yeah, I agree with you completely. What more can I say? Yeah, it's just like we can decompose the response network into the effects of network ties and the effects of these individual level parameters that govern some kind of response bias. And that might be a propensity to nominate ties that are not nominated by others as existing, and to fail to nominate ties that are recalled by others. And then, I just kind of loosely call that a false positive rate and a recall a true tie rate. And I say the opposite of recall a true tie, it's forgetting. But it could be like purposefully obscuring a tie that you don't want to mention. You recall it, but you don't want to mention it.
Right.
That's totally possible, and these statistical methods wouldn't deal with it at all.
Okay, cool. Yeah, no, I appreciate that. I mean,
Yeah. But by putting in predictor variables, if we think that a certain predictor variable might be associated with people purposefully neglecting to mention a tie that others mention as existing, then we can start to decompose it just from a base rate that's not explained by any predictor variables, and kind of decompose it into certain associations we think might lead people to over-nominate or under-nominate certain ties.
Absolutely. Yeah, that makes sense. So you could include various aspects of individual identity.
Yeah. So like, for example, people who are more depressed in a community, I have measurements of, self-reported depression, anxiety, these kinds of things. It might be that people in a social network who are, depressed, they might perceive themselves as being more socially isolated than they actually are. And that might lead to them not nominating certain names in a question about, who's given them food, who they're friends with. But they might actually, other people might nominate those ties as existing and them not. And this would be, a reason why we see that under nomination.
Yeah, great point. Cool, thank you.
Going back to the question of ecological validity, I wonder, so, the sort of on the ground ethnographic approach is, well, we're going to get all this other information about people, right? Who shares food with who, who was at the wedding, who was at the funeral, and so on, right? But maybe another way of tackling the problem would be to go to a sparser environment where the network is everything, right? So if you went to online communities where where their online interactions are all that exist, and then you were to interview those people, right, and say, okay, who do you retweet, or who do you crowd fund with, or kickstart with, or whatever it is, right? Now you have, as it were, you have the ground truth separate from your interviews. And you can apply your techniques to choices that they make and things that they tell you, and compare it to ground truth instead of working the other way. That is, if the network is everything and you have full access to the network, then you can come at it from the other direction.
Yeah. So I didn't mention it in this paper, but we do have in the Strand package, like there's another function where you can actually integrate ground truth data, and it helps you get at the effects of like the recall a true tie rate and the false positive rate. You can estimate the effects of covariates on those rates, on those parameters, much more precisely when you have some kind of network of ground truth. So, Jeremy collects like food diaries. I think, Brian with his GPS data could get out really precise data, association network data. And you could compare that to what people say. And, we could start to get an idea of, how much bias we expect at an individual level in terms of, failing to nominate certain ties and certain network questions. And that, I think, would help us appreciate, the published estimates and, how they might have been affected in various ways by these response biases.
So we should wrap it up. Talking right now?
No.
Okay. Well, thank you everyone for a great discussion and for attending this talk with Cody. And I'd just like to once again thank him for making the journey out to visit us. And we look forward to following up these questions and comments with more of your amazing research, both on the software side as well as on the theoretical side of these network analyses problems. So thank you very much, Cody. And Cody will be sticking on for a little bit here. He does have some time this afternoon. He's got appointments lined up, whether he knows about it or not, coming through the next hour, but he'll also have some additional time. So if anyone would like to chat with Cody, you can send me an email and we'll get you on his schedule. But for now, we're going to switch off the main recording and Cody will be available for those meetings. All right. So thank you, everyone. Thank you, Cody.